Well, hello everybody. This video is going to serve as a recap of intro to conic sections, how to graph and write the equation of a circle, and how to graph and write the equation of a parabola. So, as seen in class, conic sections are formed by the intersection of a plane and a double cone. So the two we're going to look at today are the circle, which is where you put a parallel cross section to the base and you get a circular two-dimensional figure. So this would kind of be like looking at the top of a styrofoam cup or the top of an ice cream cone, circular cross section. And we're also going to look today at a parabola where you slice the cone through the base or through the top, if you will, and through the side. And you get a cross section that looks like a U or U-shaped. Okay, so those are the two that we're going to focus on today. So starting off with the good old circle, a circle is the set of all points x, y that are a fixed equal distance from the center. Points on the circle have coordinates x, y. There's infinitely many of them because you can rotate around the circular curve, and no matter how closely you fit 2 points, in theory, you can always fit one in between. So any point along the curve will have an xy coordinate, and the center of the circle also has an xy coordinate, but to distinguish that from a point on the circular curve, we call the center hk, but it's still an xy thinking. And of course, the radius is the distance from the center to any point on the circle. No matter which way you go, all the radii are equal. All right, so the standard form equation of a circle is, as you see on the screen, it is x minus h parentheses squared plus y minus k quantity squared equals r squared. So x and y are going to remain x and y. H is going to be your x coordinate of the center. K is going to be the y coordinate of the center. And r squared is the radius squared. So let's take a look at how this plays out in practice. Okay, so here is an example. It says graph the circle given by the equation below. So what I'll do is under the this particular equation of a circle, I will underlay the equation in general or generic equation, x minus h squared plus y minus k squared equals 4. Excuse me, that should have been equals the radius squared. Okay, so now when you're identifying or graphing a circle, the most important facets are the center, which has so-called coordinates hk, which are like xy, and you also need the length of the radius. Okay, that will make it fairly easy to graph. So how do you extract the center information? Well, the formula reads x minus h. So since above this says x minus 3, the h coordinate is just 3. And on the y here, the y says y plus 1. However, since the formula reads y minus k, you have to take the opposite sign. So you'd really be looking at a y minus a negative 1. So the long and short of this, folks, is when you're extracting the center, what you visually see, you need to think about taking the opposite. So to me, this looks like a negative 3, but the coordinate is positive 3. And then over here, it looks like to me I'm seeing a positive 1, but the coordinate is negative 1. So it's like you're flipping the signs when you extract it out of the parentheses. Okay, so we know our center is at 3, negative 1. So I'm going to go from the origin right 3 down 1. There's the nice, beautiful center. I'm going to mark it C for center. And then the radius, note that here we have 4, but that is r squared. So if r squared is equal to 4, you would take the square root and you'd get r is equal to 2. So now we know from the center, the radius extends 2 in every dimension. So that would be up 2, right 2, down 2, left 2. Okay. So that gives you the boundaries, and now you can graph in your circle. I'm going to do it freehand, which again is not perfect, but that conveys the idea. All right. So there's your center at 3, -1, and the radius in every direction is 2. So that's the most basic idea of the equation of the conic section known as the circle. All right, remember, of course, the beauty of a YouTube video is you can pause, rewind, watch again, etc. So do what you need to do. We are going to move on here, folks, and look at another example. Okay, here it says, write the standard form equation of a circle given the following information. The center is at the origin. All right, so what do we know about the origin? We know the origin always has coordinates 0, 0. So that is our HK. And the radius is the square root of 18. So that's what our our value would equal. R is the square root of 18. So we're going to use that since it's an exact value, no rounding. But I'll draw a little thought cloud here. If you were wondering what the square root of 18 is, right? Because you'd never be at the checkout line at Kroger and they say, well, your total today will be the square root of 18, right? We don't think that way. So if you take the square root of 18, it's approximately 4.24. So we can think in our mind, you know, that's what it's approximately worth, just to have a better conception. All right, so let's see. Well, what should we do first? Should we graph it or write the equation? We can graph it first. So the center is at the origin, 0, 0. And since the radius is root 18, which is 4 in a pinch, I can go 4 units, 1, 2, 3, 4 in a pinch, each way of the center, 1, 2, 3, 4 in a pinch, 1, 2, 3, 4, 1, 2, 3, 4 in a pinch, and 1, 2, 3, 4 in a pinch. And that gives me my boundaries of the circle, and we can sketch in the circle, okay? Again, freehand, I can only do so well, but close enough. All right, now how does the equation work? Let me write out our script here. So that's always x minus h quantity squared plus y minus k quantity squared equals the radius squared. Now we'll replace our values. X remains x minus the h position of the center, which is like your x coordinate, is 0. Quantity squared plus y minus k, which is also 0 due to the origin, squared equals the radius squared. Remember, our radius, we want to use the exact value. The radius was exactly root 18, but due to the formula or the equation, it gets squared. All right, so we'll clean this up a little bit and we'll be done. X minus 0, the 0 isn't doing anything, so we just omit the 0, so it's just x squared, plus y minus 0. Again, the 0 is not doing anything, so we're just going to write down x squared. So this is a tell right here. When your x squared and y squared terms don't have parentheses, that tells you right away that you're centered at the origin, 0, 0. On the right side of the equation, the square root of 18 squared, the square root of 18 squared is just a whole 18. So lo and behold, there is your equation, folks, of the circle, centered at the origin with radius of length, square root 18. All right, we will move on to the next one. Okay, how about this one? Write the standard form equation for a circle given the following information. The center is at 6, -3, and I already pre-graphed that. My center from the origin is at over 6 down 3. I marked it C for center. They did not tell us the radius, but they told us a specific point on the circle was -2, 4, which I also marked into the picture. That would be left 2, up 4. There it is. All right. So this picture isn't 100% drawn to scale, but it's fairly close. This gives you an idea of what you're looking at. What don't we know? We don't know the radius. However, I could take my drawing tool and I could connect a radius. I could connect the center to that specific point right there. So now my green line, folks, is the radius. Okay. But we don't know its length. Okay. There are a number of ways in which you can do that to find the length or the radius. Okay. I'll mark it as this would be, let's see, R for radius, is green length. You could use the distance formula. Okay, the distance formula is a good way to find the length or distance between 2 points, and we have the 2 points. Some students with whom I've worked, they like to take this radius and think of it like the hypotenuse of a triangle and draw in a horizontal leg and then connect that to a vertical leg. Now you could do, if you wanted to, you could do Pythagorean theorem, because the distance here along the X or horizontal way, you're going from 6 to -2, which is a distance of 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8. And your vertical distance, you're going from Y coordinates of -3 up to +4. -3 to +4 is a change of 1, 2, 3, 4, 5, 6, 7. So if you wanted to, you could do a squared plus b squared equals c squared, 7 squared plus 8 squared equals r squared, solve the Pythagorean triangle, and you will get the radius. That's an option. It's a good one. The third option, which is what I'm going to go for in this video, is using the equation of the circle, x minus h squared plus y minus k squared equals r squared. And since the center is at HK, and any particular point on the curve is a specific XY, I'm just going to plug all of this information right into the equation here. The only thing that will be left unknown is R, and then we can solve for it. So this is a very convenient way to do this. If you know the center and a specific point on the circle, like I have here in red, you can just plug and chug into the formula. So again, for the equation, we keep x just as x, but since we're trying to find the radius, we'll plug in the specific point. The specific value we know for x is -2. Plug it in, bring down your minus. Our h value from the center is 6. Plug that in, parentheses squared. Plus, our specific y coordinate that the circle passes through is 4. Minus the k value from the center is -3. Parentheses squared equals, we don't know the radius, that's what we're finding out right now, so r squared. Simplify. -2 minus 6 is -8. Okay, you got to square that. Plus 4 take away -3 is like 4 plus 3, which is 7. And we've got to square that, and that equals r squared. -8 squared is 64, plus 7 squared is 49. That equals r squared. So 64 plus 49, what would that be? 113 equals r squared. Okay, that's r squared. If we want just r, that would be the square root of 113. And if you want like more of a conceptualization of how far that length is, if I grab my trusty handy dandy calculator, the square root of 113 is 10.6-ish. Okay, so in the picture, folks, I'm going to put that the exact length of the radius is the square root of 113, but note that it is approximately 10.6, which makes sense. If you look back at my picture with the right triangle, the hypotenuse of the triangle is always bigger than the legs. So this about makes sense. We have a leg of 7, a leg of 8, and now The radius is root 113, which is approximately 10.6. So everything makes sense. All right. So to clear some room to finish off answering the question we started out with, write the standard form equation of the circle. We have all of our info. We've got the center, HK. We've got the radius is exactly root 113. So I am going to clear off some of this work here. And we will write the equation as fast as I can erase. All right, here we go. So in the equation, we leave x as x because that represents its variable. As you swivel around the circle, your x coordinate is going to constantly change, minus the center doesn't change, that's fixed. And remember, h is like your x coordinate on the center, so that's a 6, parentheses squared, plus y. Remember, you leave it as y because as you move around the circle, the y coordinate will change. Okay, it's continually changing as you're moving around the circle. Minus the k value is -3. Plug that in. Parentheses squared equals, we know the radius now, it's exactly root 113. And we're going to square that. All right. So now we'll simplify and we will be all set. Okay, x minus 6 squared, that's part of the standard form, plus y. The minus minus or minus a negative looks funky, that becomes a plus 3 squared. And we know that when you square a square root, you get just the number inside, which would be 113. So there you have it. That is the equation of this particular circle pictured at the left with center 6, -3. The radius is the square root of 113, which is about 10.6. And the circle goes through infinitely many points, one of which, a particular one, is this red point, -2, 4. So I hope that makes sense. And we will move on once again. Remember, you can always pause and rewind. That's the beauty of YouTube. And speaking of pausing and rewind, you might want to pause right now and try these two on your own. It says, identify the center and radius of the circle. You've been given the equation. So center, I'll call C, and radius, I'll call R. Center, which we call HK, and radius we'll call R. Okay, if you want to pause it right now and give it a shot and then unpause to see the solution, go for it. So again, like we talked about a moment ago, in the first circle, x squared plus y squared equals 49. There's no parentheses, which means there's no shift on the center. So it's at the origin 0, 0. Remember that this part of the formula here is r squared. So if r squared is 49, r is the square root of 49, which is just 7. Okay, so center 0, 0, radius 7. In the second example, since we see x plus 2, I know that the coordinate for the h for the center is -2. And my eyes see y minus 7. So I know my k value is going to be the opposite sign, +7. So this circle is centered at -2, 7. And I know from the formula, this is r squared. So if r squared is 16, the radius is root 16, which is just a whole 4. At this point, you could graph them. You could do whatever you want. Once you have the center and the radius, you are good to go as far as drawing a circle. All right, so that concludes the circle portion of this lesson, or lesson recap. Now we will move on to the good old parabola. All right, let's take a look. Well, most of you know that a parabola is a U-shaped curve. So here's two different pictures. The left one is using like an orange-shaped parabola. And on the right, it looks to me more like a red. So a parabola is the collection of all points equidistant from a point called the focus and a line called the directrix. So here, if we first look at the left picture, you see your parabolic curve. There's an axis of symmetry cutting it in half like a fold line or symmetry line. The most important point is the vertex, which is where it bottoms out. That is kind of, to me, like where it starts, where it sprouts from. Okay, a parabola is not going to have a center, but it has a vertex, which will still be HK. That's where it sprouts from. The focus is a special point inside of the parabola. It's kind of like the parabola swallows it like Pac-Man, like a little pellet. And the directrix is the same distance from the vertex to the focus, but in the other direction. So if the vertex is here, the directrix isn't going to go up, but down. And it is in this case, a horizontal line. So the directrix is perpendicular to the direction of opening of the parabola, which we'll talk more about as we go. And now if we look at the picture on the right, what that is showing you is what makes a parabola is the following. If you put your pencil on the focus point inside, it's like it's swallowing it, like a whale swallowing a minnow. If you draw a straight line from there to a particular point on the curve, and then from there go straight down to the directrix line, those two yellow lines will be the same length. Okay? If I go back to the focus, and now I go this way to the curve, whatever that length is, it's the same length as from the point on the curve down to the directrix line. And it doesn't matter which way we go. I could start here at the focus. I could go this way. I don't know exactly what that length is, but I do know that it will be the same length if I drop straight down here to the directrix line. So that fixed distance or equidistant property is what makes a parabola a parabola. All right, so now let's check out what the equations look like. So the parabola can open 4 different ways. It can open such that it's heading upward, where the vertex will be at the bottom. That's where it bottoms out, and the branches head upward. Okay, in that case, you use this formula, where the x minus h squared is on the left. 4p, which is a coefficient we'll talk about, is on the right of the equals, and then you're multiplying by y minus x. So how I remember this is I look on the right side, I look on the non-squared side. So I see regular y, which reminds me of y-axis. Y-axis is vertical. And then I look at this coefficient part, and since this is a positive 4, I know that things that are positive and vertical open up. So that's how I remember this is the equation of a vertical upward parabola. Let's contrast that to the next slide, which now we have a parabola that opens down. So the vertex is at the top, or we call it a maximum, and the branches of this parabola are heading down. So again, I got my square term on the left. On the right, I have plane y. So y is telling me, okay, I know the y-axis is vertical. Okay, I can dig that. And then I look in front here, and this coefficient is a negative. So vertical and negative is going to reflect me down. So this parabola is heading down. Okay, so those are your 2 equations for a vertical parabola that either heads upward or downward. So next, let's look at what happens if it is horizontal, which means left or right. So if we take a look, here is the equation of a horizontal type, which opens to the right. So if you look again at your picture, now the vertex is the leftmost thing in the picture, but the curve opens up to the right. The arrows are literally pointing to the right. So you got y minus k squared. Okay, fine. You have 4p here, which is a positive coefficient. And then you have the x variable. X reminds me of x-axis, which is horizontal. So things that are positive and horizontal head to the right on a coordinate plane. So that is a way to think about and internalize why this would open to the right. So if you have a right horizontal opening parabola, you will use this equation. And then you might guess now what little tweak you'd have to make to this to have it open to the left. So if we look at our final variation, here is a leftward opening parabola. Note that the vertex is the furthest most thing to the right. Okay, sorry about that. Okay, notice that the vertex is the furthest thing to the right, furthest point on the curve to the right. The branches keep going forever to the left, so we call this opening left. So if you look here, okay, you've got your squared business. We're not really looking at that. So over here, you have a negative coefficient, and then you have an x. X is reminding you of horizontal. So if things are negative and horizontal, you're moving to the left, which is the direction in which way the curve is opening. Okay, so there are your 4 variations of the standard form of the equation of a parabola. So now we will put this into practice. All right, identify the vertex and direction of opening, and we're going to make a very crude sketch. So I noticed that in number 1, I'm starting with x plus 5 squared. So the squared term is on the left. I'm going to kind of ignore it. I'm going to notice on the right side of the equation, my coefficient here is positive. And you're going to say, but it's a number now. It's not 4p. We'll get to the 4p thing in just a minute. Note at this point that the coefficient in front of the parentheses is positive, and this is the y variable, which you're thinking y-axis is vertical. So if you have a positive coefficient in vertical, this is going to open upward. All right. And the vertex, which is like the point from which the parabola sprouts, if you will, is going to be hk, similar to the center of a circle. So the h is the opposite of what you see after the x. So over here, your eyeballs see a positive 5 after the x. You're going to write down the opposite sign, negative 5. And then your k comes after y. So even though you see a plus 1, you're going to go negative 1. So now if I made a really quick and crummy graph, my vertex is negative 5, negative 1. That'd be left 5, down 1. So my vertex would be here. And this one is opening upward. So it looks something like this. Okay. Now I said this would be crude. There's also a focus point. There's a directrix line. We could set the width better. This is just a very crude way to see where does the parabola start? Where is the vertex? And then which way does it go? Up, down, left, or right? That's all I care about right now. Okay, number 2, note that we have the x minus 4 parentheses squared first. All right, so now I'm really focusing more on the other side of the equal sign. So I'm noticing that I have a negative here. Okay, so I have a negative coefficient, and I have the plain y variable. So y things are like the y-axis, they're vertical. So since this one is negative vertical, it's going to open downward. Okay, so I know which way it's going due to the equation. It's opening downward. And I need the vertex. So the vertex is HK. So I look and I see, okay, what do I have after X? It looks like -4, so I'm going to go +4. And then after the Y, I see with my eyes a +2, so I know that the coordinate is -2. Now, if I knock out a really crummy little graph here, my vertex is at 4, -2. So that's 4 to the right, down 2. So there is my beautiful vertex. And this one is opening downward. So the curve is going to look something like this. Okay, again, how accurate is this? It just gives you a very rough idea. Where does the parabola sprout from and which way does it go? Again, we've not yet gotten into plotting the focus point, the directrix, or anything more sophisticated, but this is a really great start to conceptualize which way does it go and from where. So in recap, there are two examples of vertical parabolas. Number one, opening up. Number two, opening down. So you might guess where we're heading next. We're heading to look at a couple of horizontal parabolas and why they are the way they are. So in number three, we start with y plus 5 squared. So the squared ingredients are on the left. That's good. Notice that after the equal sign, we have a negative coefficient, negative, and then we have x, and x-axis stuff, movement is horizontal. So this parabola is going to be negative horizontal, which means it opens left. Okay? Think about if you were walking to the negative numbers horizontally on the number line, you'd be moving to the left. So we've got that. We know our vertex is going to be HK. So I'm trying to find, and remember HK is kind of like XY. So here's my X coordinate. After the X, I see a -1. So that becomes +1. K, my Y vertex point. I look for my Y, I see a +5, -5. All right. Really quick little graph just to see the very basics. I know it's going to have a vertex or sprout from 1, -5. So that'd be over 1, down 5. So somewhere there, okay, that's going to be my vertex. And it's going to sprout to the left. So it's going to look something like this. Okay. Did I get the width right? No, that's actually quite poor, but that does give you the basic idea. Okay, so we're not trying to set the world on fire here with the width and the directrix and the vertex, just the generalist of general ideas of how it looks. Which finally would bring us to number 4. So again, I got my squared stuff over here. That's good. To the right of the equal sign, I notice that I have a +2, which is a positive coefficient, and I have x, which is horizontal information. So this is going to be a positive horizontal parabola, which of course opens to the right. I can also find the vertex, which is like from where it sprouts. That's kind of how I think of it, like a little seedling. And that would be HK. And H tells me to look at the X coordinate, even though my eyes see a +3, that reverses to -3. And K, I find my Y variable and I see a +2, that reverses to -2. Okay, real quick little XY coordinate plane. -3, -2 is in the third quadrant, left 3, down 2. There is my beautiful vertex, V for vertex. And the curve is going to open to the right, so it is going that way. Just to give you a general idea. So I hope my explanation of standard form of a parabola makes sense, how you can decipher which way does it open, up, down, left, or right, and how to extract and graph the vertex. All right, so with that in mind, folks, let's head into the final stretch and look at a little bit more of a detailed example. Next, it says, write the standard form of the equation of the parabola with the given characteristics. Okay, and we're going to graph it. Or better yet, we're going to use the graph to better understand how to write the equation. Okay, so what do we know? We know the vertex where it sprouts is at 0, 0, or the origin. So I'm going to plot that on my graph. Okay, and I'm going to call that V for vertex. And then we also know that the focus or special point of the parabola is at -2, 0. So -2, 0 from the origin takes me left 2 and then don't move. So it's right there. And I'm going to put an F for focus. Now, you may say to yourself, well, I wasn't told which way does the parabola open, but subliminally, yes, you were. The focus must be swallowed up by the parabolic curve. So for example, let me show you, I'm going to do this wrong. If I thought, well, yeehaw, maybe the parabola looks like that. The parabola can't look like that because the green curve didn't swallow like a fish. It didn't swallow the focus, or think about like Pac-Man. If I say, well, golly gee, maybe it goes this way, that can't be right either because it didn't swallow the focus right down the middle of its gullet. So the only option is for it to go this way because the focus and the vertex have to be lined up on an imaginary symmetry line. I will put that in yellow for you to see. This would be an imaginary axis of symmetry. Okay, that is going to cut the parabola literally in half. If it was drawn to scale, you could fold it in perfect mirrored halves. All right. So once again, if the information is we have a vertex and we have a focus point, that does tell you which way the parabola opens because it has to swallow the focus point. So now we know that this is a horizontal parabola. It's horizontal, and even more specifically, it opens to the left. So if you look back on the previous slides, since it opens to the left, I know that I will have a negative 4p coefficient. Horizontal is x minus h. So on the left side, therefore, I would have my y minus k squared. Okay? So remember, x here is horizontal and negative is left. That's how I was able to do that without literally looking at a cheat sheet or notes. I've just kind of memorized how it works, so to speak. So now we can chug in the information. So we have y minus k. Remember, your vertex is hk. So our k here is 0, parentheses squared, equals negative 4p. What in the world is p? Well, we're going to get to that in just a jiffy. Times x minus h. Again, the h coordinate of the vertex is also 0, like that. Now, you'll notice in those previous examples, you don't see 4p, you see a value. So how do we replace this with a value? Let me show you. By definition, p is equal to the distance from the vertex V to the focus F. Okay? Along the axis of symmetry, you're staying on the yellow brick road or the yellow line. So if I keep this color orange here, if I literally count the distance, folks, from the vertex to the focus, in this one, I'd be going 1, 2 units. Okay, I'd be going 2 units. So my p-value here is 2 because I'm going 2 units from the vertex to the focus. 1, 2. I hope that makes sense. So since that distance is 2, I can pop that into the formula. So now I'm going to have a recopy. Remember, this minus 0 isn't doing anything, so I'm just going to write y squared. That's a more succinct and better way to write it, equals -4 times p, I know from my drawing, is worth 2, times, again, x minus 0. The minus 0 isn't doing anything, so I'm just going to put x. And then finally, we have y squared equals -4 times 2 is -8, and then bring down my x. So the fact that I have no parentheses left in my answer is a flag that the vertex is at the origin, 0, 0. And I know that since it's a -8 coefficient on the x is horizontal and -8 is left. So it all seemed to make sense to me. The only thing else I want to teach you here is where to put in the special line called the directrix, It goes back to this p-value. If the p-value was 2, meaning that from the vertex, we went 2 left to get to the focal point F. From the vertex, we went 2 to the left. Go back to the vertex and now go 2 to the right. 1, 2, we're right here. And the directrix is always perpendicular or making like a T or a cross with the axis of symmetry. So since my yellow axis of symmetry line is going horizontal, this directrix here must go vertical, okay? And its equation is all about where does it cross the x-axis here? It crosses the x-axis at 2. So its equation is literally x equals 2. This is called the direct tricks are for kids line. The directrix is x equals 2. All right, so that's more information. So now we have the vertex from where it sprouts, the direction of opening. We have the focus, which is the special point that it gobbles up. That's how satellite dishes and headlights work with this focal point. And then the directrix is the fixed distance line the other way. All right, if you want to go look back at that one, folks, you can always rewind. Let's look at yet another example. Okay, this time I'm giving you the focus and the directrix. No vertex information. That kind of leaps out at me. So I'm thinking, where is the vertex? So I'm going to put vertex, HK, question mark, question mark. They didn't tell us. Dadgummit, but we're tough. We'll find it. All right, so what do we know? We know we have a focus at 2, 2. So here's my handy dandy graph. Again, you don't need fancy graph paper. If you can print some, great, but just do a little crummy sketch on blank white paper. The focus is at 2, 2. So from the origin, we go over 2, up 2, bam. That is the focus. All right, so I'm gonna put F for focus because I like to have my work labeled so I remember what's what. And let me go to, let's see, how about purple? The directrix is x equals -2. Remember, the directrix is a line. So x equals -2 is a vertical line. It has no slope, undefined slope. It's a vertical line and it crosses the x-axis at -2. So if we're going to cross the x-axis at -2, let's go to -2 on the x-axis right here. And it is a vertical line, folks. X equals lines are vertical because they cross the x-axis. They're parallel to the y-axis. They cross the x-axis. Okay? So that's your directrix. D for directrix. Its equation is x equals -2. So now I know something else. I know that the axis of symmetry that cuts the parabola in half is perpendicular or makes a cross with the directrix and it goes through the focus. So here is my imaginary axis of symmetry that will literally fold my parabola in half whenever I draw it. Okay. And I also know that my vertex point must be halfway between the green focus and the purple directrix along the yellow line. So here I'm at +2 for the focus. Here I'm at -2 for the directrix. Halfway between +2 and -2 is here. So I'm at 0, 2. So now I have found my vertex. My vertex is halfway again. It's right smack in the middle between the focus and the directrix line. Your vertex in this case is at 0, 2. All right, so due to the symmetry of this picture, if they give you the focus and directrix, you can find the vertex. You can. All right. So now we got vertex, focus, directrix. I can graph in the parabola. So let me go to black. So I know that the parabola can't cross, it can't crash into the directrix, it can't. It has to swallow the focus sprouting from the vertex. So the only way it could do that is going to the right. Something like that. Notice that my yellow imaginary axis of symmetry is like a fold line, folding it in mirrored halves. It swallows the focus, it sprouts from the vertex. The directrix is, it's going away. The arrows are going away from the directrix line. The directrix line is always perpendicular or 90 degrees to the axis of symmetry. All right. So now I learn more information. We know that this is a horizontal parabola and it's opening to the right. So now I know which formula to use. Okay, so I'm going to put my equal sign on the right side. I know that I have that 4p coefficient. And since to the right is a positive direction, that's going to be positive 4p times horizontal is an x concept minus h. So therefore, the left has to be the y minus k squared. Okay. So before we plug and chug, I know I'm going to need the p-value. So now I'm going to, let me grab orange. I think to myself, p is the distance from the vertex to the focus. So that would be from here, folks, that would be 1, 2. So p equals 2. Or I could go from the vertex to the directrix, same thing, along the axis of symmetry, 1, 2. Okay? So the p-value is 2. I got my h and k from the vertex, and y and x are my variables. So we are good to go. So let's do it. We have y minus k. K from the vertex is 2, parentheses squared, equals positive 4 times the p-value, which from my picture was 2. Okay? Parentheses, x minus h, the h value from the vertex was 0. Okay, next step, just to clean it up, we've got our y minus 2 squared equals 4 times 2 is 8. And then x minus 0, the minus 0 isn't doing anything, so I'm just going to bring down my x. So there you have it. That is the equation of this very parabola with these characteristics. Focus at 2, 2. Directrix at x equals -2. Therefore, the vertex is at 0, 2, etc. It all falls into place. All right, my friends, we are going to look at one last example after this. So if you need to pause, take a break, go get a drink of water, rewind, again, do what you have to do. I'm going to hit erase right now, and we will move on to the final example, which is this guy right here. This one gives us the equation. We are asked to find the vertex, focus, directrix, and sketch. So now we have to extract. So the first thing I'm going to notice is my squared term is the x. So my x minus h information is right here. And I notice that the non-squared information is right here, but this is not in standard form. Standard form has your squared information on the left of the equal sign and the non-squared stuff, the linear stuff, on the right. So to adjust for that, I'm going to put in a set of train tracks on both sides of my equals just to really clearly delineate the left side versus the right side. And I'm going to subtract the 8 times y plus 3. Whatever I do to one side, I do to the other. All right. So now I'm going to bring down this x plus 1 quantity squared. This plus 8 minus 8 term, these cancel. And then on the right side of the equation now, I've got 0 minus 8 is negative 8 times y plus 3. Okay, now this to me looks a heck of a lot like standard form. Okay, get rid of my train tracks. And again, I'm not really focusing on the square term. I'm looking at the other side. So now what does this tell me? What do I see? I see a negative coefficient and I see a y. So negative y goes down. So this is a downward parabola. It's a downward parabola. So that is a start. Now I can extract the vertex. I can extract the vertex. So the vertex, folks, remember, is always hk. So remember, h is tied to x. So x I see plus 1, but I reverse it to negative 1. K is tied to y. I see y plus 3. That changes to a negative 3. So if I want to pop over to my graph, I can plot the vertex. That's the point from which the parabola sprouts, so to speak. That's at negative 1, negative 3, negative 1, negative 3. Okay. So that's my beautiful vertex, V for vertex. And I know it's going to open downward. So I can sketch the curve if I want. It's going to go something like this. Yeehaw. Now, is that perfect? No. But right now it's close enough for government work. And I know that if I want to, I can put in my imaginary axis of symmetry, which splits it in half, which would be, whoa, no, I thought I had the straight line drawer. Okay, let's try that again. That has to go through the vertex and it has to split the parabola into mirror images. So actually that, now, in fact, now that I have that there, perhaps I could freehand it a little bit better. I'll change colors too. So how about like that and like that? Do I have the width of this thing set really well? No, but that's still just not high on my priority list. Okay, so we were able to extract the vertex, HK. So that's done. We got that check. How about the focus? How do we put in that focus point? Well, that is all about the p-value. So look in front of your parentheses right here in front of the y parentheses. That's a negative 8. So remember, part of the formula is always 4p. So 4p in this case is negative 8. All right. So 4p equals negative 8. You want p by itself, divide both sides by 4. So p would be equal to negative 8 divided by 4 is negative 2. So your p-value of negative 2 is also subliminally telling you that this opens downward. So now if I put my pencil on the vertex and walk down to 1, 2, here is my focus point, which I will call F. Remember, the focus point has to be inside, getting swallowed by the parabolic curve. If not, you did something wrong. And this p-value of -2, or if you think the absolute value of 2, that tells you how to find the directrix. So if the focus from the vertex went down to, the directrix has to go from the vertex up to, plot a point, and the directrix has to be perpendicular or make like a T or a cross with the axis of symmetry. So it has to go this way. It cannot crash into the blue parabolic curve. So that orange line is the directrix. Okay. What is its equation? Well, it crosses the y-axis. It crossed the y-axis right here. It's crossing the y-axis at -1, so its equation is y equals -1. That's a horizontal line with 0 slope, y equals -1. So we got that, check. And we've got our focus point in here, folks, in green. I just didn't write down its coordinates. So to finish this off professionally, we can say the focus is at, let's see, from the origin, that would be -1, -5. 1, 2, 3, 4, 5. -1, -5. Bam. So that's what I wanted. I wanted to see the picture. I wanted the vertex from where it sprouts, the focus, which is the special point that the curve gobbles up like Pac-Man, and the directrix, which is in the opposite direction of the focus. All right, I hope I explained this well for whomever is in YouTube land. Hopefully this video helped you absorb a little bit more about the basic bare bones of the conic sections of the circle and parabola. So stay tuned for future episodes. Good luck with your studies and have a superb day.